Good day and welcome to our class on the Cauchy sequence. Today's class is going to be a continuation of our previous class or previous lessons on Cauchy sequence, because we'll be proving that certain sequences are Cauchy. We begin from the first one. Prove that sequence A sub n equals n squared over n squared plus 1 is Cauchy. The first thing we have to do is to recall our definition of Cauchy sequence. By definition, A sub n is said to be Cauchy if for every epsilon greater than 0, there exists a p belonging to the set of natural numbers such that the absolute value of A sub n minus A sub n is less than epsilon for all m and n greater than p. Therefore, the first thing we need to do is to identify a p that works. We begin from A sub m minus A sub n. Our A sub n is n squared over n squared plus 1. Therefore, A sub n will be n squared over n squared plus 1. A sub m minus A sub n will be m squared over m squared plus 1 minus n squared over n squared plus 1. And this will give us m squared into n squared plus 1 minus n squared into m squared plus 1 all over m squared plus 1 into n squared plus 1. This then gives us, by the time we open the bracket, we have m squared n squared plus m squared minus n squared m squared minus n squared over m squared plus 1 into n squared plus 1. This cuts this. We are left with m squared minus n squared over m squared plus 1 into n squared plus 1. And by the triangle inequality, that is less than or equal to m squared over m squared plus 1 into n squared plus 1 plus n squared over n squared plus 1 into n squared plus 1. But 1 over m squared plus 1 is less than 1 over m squared, and 1 over n squared plus 1 is less than 1 over n squared. So I'm going to replace this by 1 over m squared so I can have something to cut. Therefore, this is less than m squared over m squared into n squared plus 1. The same thing happens there, plus n squared over n squared into n squared plus 1. And then this can cut this can cut this. That is less than 1 over n squared plus 1 plus 1 over m squared plus 1. And this is less than 1 over n squared plus 1 over m squared. Because we want both of these to be less than epsilon, we can take, let 1 over n squared be less than epsilon over 2. And by the time we solve that, we have our n squared to be greater than 2 over epsilon. And that means that our n is greater than the square root of 2 over epsilon. And similarly, 1 over m squared is also less than epsilon over 2, which implies that our m will also be greater than the square root of 2 over epsilon. Therefore, what we have there will be less than what? 1 over 2 over epsilon plus 1 over 2 over epsilon. And that is less than epsilon over 2 plus epsilon over 2, which is less than epsilon. That implies that a sub m minus a sub n is less than epsilon. So we'll now go ahead to prove it now. Since m and n is greater than p, and n is greater than, or better yet, and n is greater than square root of 2 over epsilon, or n squared is greater than 2 over epsilon, as we have there. Therefore, our p is such that p squared will be greater than 2 over epsilon. Therefore, we want to prove, let epsilon be greater than 0 and p be such that p squared is greater than 2 over epsilon. We want to now show that a sub m minus a sub n will be less than epsilon. So we are going to perform all the algebra that we have done before. This will give us m squared over m squared plus 1 minus n squared over n squared plus 1. And this is less than or equal to what? M squared over m squared plus 1 plus n squared over m squared plus 1. And so we have that by triangle inequality. And then this, just as we have written here, is less than this plus this, will be less than 1 over n squared plus 1 over m squared. But m and n is greater than p, therefore a sub m minus a sub n will be less than 1 over p squared plus 1 over p squared, because this implies that p is less than m, p is less than n. And we have said that p squared is greater than 2 over epsilon. Therefore, 1 over m minus 1 over n is less than 1 over 2 over epsilon plus 1 over 2 over epsilon. And that is less than epsilon over 2 plus epsilon over 2. That is less than epsilon. Therefore, the sequence a sub n equals n squared over n squared plus 1 is Cauchy. We'll take another one and prove that the sequence is Cauchy. For our second example, suppose x sub n is a sequence of real numbers such that the absolute value of x sub n is less than 3n squared minus 2 over 4n cubed plus n squared plus 3. Prove that x sub n is Cauchy. We want to prove that x sub n is Cauchy. Again, we recall that a sequence is Cauchy if For every epsilon greater than 0, there exists a p belonging to the set of natural numbers such that the absolute value of a sub n minus a sub n is less than epsilon for all mn greater than p. So the first thing we want to do is to choose our p. We begin from x sub n minus s sub n. And if this is our x sub n, then our x sub m will be 3m squared minus 2 over 4m cubed plus m squared plus 3 minus 3n squared minus 2 over 4n cubed plus n squared plus 3. And then by triangle inequality, this is less than or equal to 3m squared minus 2 over 4m cubed plus m squared plus 3 plus 3n squared minus 2 over 4n cubed plus n squared plus 3. But we know that 3m squared minus 2 over 4m cubed plus m squared plus 3 will be less than 3m squared over 4m cubed. And similarly, 3n squared minus 2 over 4n cubed plus m squared plus 3 will be less than 3n squared over 4n cubed. And so we can use this to replace that. We have x sub n minus f sub n to be less than the absolute value of 3m squared over 4m cubed plus 3n squared over 4n cubed. And that is less than 3 over 4n plus 3 over 4m plus 3 over 4n. And by the time we factor out the 3 over 4, that is less than 3 over 4 into 1 over m plus 1 over n. But we want that to be less than epsilon. Therefore, we know that this is less than 1 over m plus 1 over n. And so, let 1 over m be less than epsilon over 2. It means that m will be greater than 2 over epsilon. And similarly, n also will be greater than 2 over epsilon. Therefore, our p will be greater than 2 over epsilon, since m and n are greater than p. Since m and n are greater than p. We then go ahead now to prove that the sequence is Cauchy, having identified our p. We want to prove that the sequence is Cauchy. Take epsilon greater than 0 and p such that p is greater than 2 over epsilon. We want to show that x sub n minus s sub n will be less than epsilon. So as we did before, this is equal to 3m cubed minus 2 over 4m cubed plus m squared plus 3 minus 3n cubed minus 2 over 4n cubed plus n squared plus 3. And by triangle inequality, this is less than or equal to 3m cubed minus 2 over 4m cubed plus m squared plus 3 plus 3n cubed. It should be 3n squared. The power should be 2 and not 3. 3n squared, because that's what we have in the question, minus 2 over 4m cubed plus n squared plus 3. And this is less than 3m over 4m cubed, 3m squared over 4m squared plus 3n squared over 4n cubed. This is less than 3n squared over 4m cubed plus 3n squared over 4n cubed, and that is less than 3 over 4m plus 3 over 4n, and that is less than 3 over 4 into 1 over m plus 1 over n, and that is less than 1 over m plus 1 over n. And since m and n is greater than p from the definition, it means that 1 over m will be greater than 1 over p, and 1 over n will be greater than 1 over p. Therefore, the absolute value of x of n minus f sub n will be less than 1 over p plus 1 over p, and we have chosen our p to be greater than 2 over epsilon, which implies that 2 over epsilon is less than p. So x of m minus x of n is less than 1 over 2 over epsilon plus 1 over 2 over epsilon. That is less than epsilon over 2 plus epsilon over 2, and that is less than epsilon. That means the absolute value of f of n minus s of n is less than epsilon, which implies that the sequence x of n, which is less than 3n squared minus 2 over 4n cubed plus n squared plus 3, is a Cauchy sequence. We have been able to prove that that sequence is Cauchy. You can try this and determine whether the sequence A sub n, defined as 2n plus 1 over 3n minus 1, is Cauchy. If you are able to solve that, and if you are able to determine whether it is Cauchy or not, leave a comment for me. Thank you, God bless you, and I see you in the next video.